abbreviated way of doing the study guide workbook using slides. I'll try to get through them real quick. Anywhere between 10 to 20 minutes, maybe even a half an hour in some of these. So we're going to be looking at identify basic facts about radio theory, which is the transmitter portion. There's three portions in this section. We have transmitters, receivers, and transceivers. Just remember you can have to get 70% on your KPC, which is, I think there's 12 questions in one alpha, and of course the transmitters, receivers, and transceivers are all in it. I think one Bravo has 10, and those hopefully will be the ones that you're taking on probably Wednesday starting, because it takes some time to get through these as well as the one Bravo. Let's look at the AFSC application. Big thing is you're going to deal with transmitter throughout the rest of this course. It may be in combination with receiver, called a transceiver. It may do several different things for you, but we always have to go back to the basics, explain a little bit about a transmitter. We're going to be looking at transmitters, power supply, the oscillator, the audio amplifier, modulator mixer, the RF amplifier, not to be confused with the audio one, and RF control, antenna coupler tuner, and signal flow. Let's start with what the heck is a transmitter? It's an electronic device. No kidding. What's it used for? To radiate out information. You needed antenna with it. When I came through my first blocks in Jones Hall for what used to be ground radio, I had no idea what an antenna was when I went through. We're now starting to put that antenna together with the radio. Makes more sense. When we have the breakdown of this, we're looking at a block diagram. We're not going to get into component level, even though I could, but it doesn't make any sense to do so since most of the devices now are either line replaceable units or just remove and replace the whole radio. But you got to determine whether or not it's the radio itself or if it is something that's causing the problem within the radio, like the cable, the antenna, connector on your mic, and so forth and so on. So let's break this down into each individual module. First of all, we got the power supply. What does the power supply do for us? Well, you plug it in, you turn it on, and hopefully everything works. So with the power supply, you got to have this going to other modules. Without the power supply, the radio doesn't work. First and foremost. Turn the switch on, you hope everything works. You'll know when you key that puppy up. If the lights are on, normally it's going to work. But there are other things. You guys have used the test equipment. You guys still have a radio in the test equipment lab? Okay,
Yes.
so when you key it up, you get an output on your test equipment. We're going to go through that. We look at an oscillator. What the heck is an oscillator? Anybody know? Jacobs, any idea what an oscillator is? Jacobs.
Yes, sir.
You know what an oscillator is?
Yes, sir. It's converting DC into
Okay.
AC.
So basically, it's an AC circuit that needs power from the power supply. The idea behind an oscillator is I'm going to need it to produce a frequency for me. How does it keep stable? Well, first of all, you got to get a good oscillator. And second, you need something called phase-lock loop to keep it on point. In other words, I don't want my frequency drift. Drift is a big problem. Audio amplifier, well, when you speak into that microphone, it's weak, believe it or not. All you're doing is you are using your voice to vibrate a piece inside the microphone, and when it gets to the radio, it's pretty doggone weak. So we need an audio amplifier in order to send it to the modulator to get mixed. Which brings me to the modulator. Whole idea behind the modulator is to combine that oscillator frequency with the audio. The idea here is I'm going to carry that audio to the distant end. With the RF amplifier, the whole idea is anytime you mix a signal, you're going to have to filter it and amplify it. You're going to hear about filters later on down the line. With that amplifier, without it, you can't send it out through the antenna. And the reason is if you don't have enough power to get it to the distant end, why do you have an amplifier? So the whole object is to get microwatts or milliwatts up to some type of wattage that can get it to the distant end. Depends on your equipment as to what the output power needs to be. When we look at RF control, what you don't want to happen is have that amplifier go nuts on you and decide to amplify everything into great measures. That's where the RF control comes into play. The idea is if I set my radio at 10 watts, I want it to be at 10 watts all the time. Now, there is a percentage, like 10%, it might be going down to 9 watts or 11 watts, but as long as it stays within that acceptable range, we're fine. I don't want my radio to produce 20 watts when it's supposed to be doing 10. Figure, huh? The whole idea is if I blast the frequency spectrum with a lot of wattage, believe it or not, it has a tendency to spread and can interfere with other frequencies, especially if it gets mixed at a distant end, cause interference. We have something called an antenna coupler and tuner. The first one we're going to talk about is the coupler. The whole idea is depending on where it's placed will determine if it's a coupler or tuner. They are either manually or automatically tuned. What does it do? Well, you're going to find out later in the other objectives why that coupler and tuner are needed. Let me give you a background. The whole idea is to match the radio's frequency and the impedance that the radio and cable have to the antenna. So with radios, they're always 50 ohms. I've not seen a radio anything else other than 50 ohms internally. TVs, on the other hand, are 75 ohms. Don't get those two cables mixed up. If you've got some type of VIDS, visual intrusion detection systems, might be with you or in the same work center, they'll work with 75 ohm lines. So you can see right away that if you mix those lines up, your coupler is going to have to work a little bit harder in order to make everything look like it is a 50 ohm impedance. So couplers are placed at the antenna. The tuners are located close to the transmitter, in some cases internally to the transmitter. You're going to find that out later down the road. So now we're going to look at transmitter signal flow. The big thing about transmitter signal flow is you got to figure out what is happening where in order to figure out where the problem is. For example, if I am transmitting out a signal and it's supposed to be modulated, and I can see it when I put, let's just say, a spectrum analyzer or even an oscope on the end of it to look at that modulated output, and I'm not getting it, I just don't want to ditch the radio right away. It could be the mic, cable, it could be the radio, it could be the oscillator. You don't know. So you got to figure this out by using the signal flow. Let's take a look at this. Well, first of all, with anything, when you flip that switch, the power is going to go to all the modules. The big thing is when I key the radio, and keying the radio is pretty significant. What does keying the radio mean? Well, normally you're pressing that little button and then you're speaking into the microphone. That's your audio. Excuse me. When you key that radio, of course, with the power being supplied to all the other units or modules, that is going to go into the audio amplifier. The audio amplifier is going to amplify it, and then it's going to send it to the modulator. Now, with the oscillator, this is going to generate what we call a carrier. This carrier is controlled by phase lock loop. Phase lock loop keeps it on frequency. You can see down here on the spectrum analyzer, it is nothing more than a single frequency. And when you look at the O-scope, it's just full. It's just completely full on that O-scope. It's also going to be sent to the modulator. When we get to the modulator, it's going to combine those signals. And you can see with the spectrum analyzer on the bottom left, you're going to have 3 signals. And when you look at the O-scope, and you can differentiate between the upper and lower sidebands on that carrier right there, and it looks like it's about 90 or so % modulated, so it's a good modulation there. And the big thing about this, where in the heck did the audio go? So if I had, let's just pretend here, if I had my oscillator, well, let's just say I have my radio selected at 300 megahertz. My oscillator is going to generate 300 megahertz. Key the radio, I'm going to speak into it. Let's just say I've got an audio oscillator on it. That way I get a steady tone and not my voice going all over the place. And it gives a 1 kHz tone. So when it gets up to the modulator, you're going to have an upper and lower sideband. Well, where's the audio? Audio's in the sidebands. Well, where's the 1K at? Well, due to the fact of the frequency of 300 megahertz, you're going to have 300.001 megahertz, and then you're going to have 300 megahertz, and then you're going to have 299.999 megahertz. That's your upper and lower sidebands in the carrier. Nowhere in that picture would you see the audio. It's because of the impedance of the circuit that eliminates it. Kind of crazy, I know. But your audio is already carried with the carrier. We go to the RF amplifier because we've modulated it. Now we got to boost the power. And then we're going to control it, because the last thing we want to do is get it out of sorts. That if I want 10 watts and I get 20 watts, I got a problem. Or if I produce, if my radio is producing 10 watts and I only get 2 watts, might be a problem. Now, it comes under different names for RF control. You're going to see this throughout the course. You may see things like TGC, which is transmit gain control. You're going to see ALC, which is automatic load control. APC, automatic power control. All these are under the same guise of controlling that output so we don't get too much or too little wattage here. When we go to the coupler tuner, this whole idea of the frequency with the tuner, we're going to match that frequency with the signal as well as the impedance of the antenna, because each frequency has a different impedance when it gets on the circuit. We'll show you that later. And then, of course, the antenna. You need the antenna in order to radiate out to the distant end. So we've gone through transmitters, power supply, oscillator, audio amplifier, modulator, mixer, the RF amplifier, RF control, the antenna coupler, tuner, and signal flow. Pretty quick, wasn't it? About 15 minutes? Any questions?